Hey everyone, welcome to another coffee session. I'm your host, David Aponte, and I have a special guest with me, my coworker, Neeran Gul. Neeran Gul is a 10-year industry veteran with a lot of experience working with major cloud providers, so AWS, Azure, GCP. He's also contributed to a bunch of open source projects like Terraform and Ansible. He loves writing about all of his technical discoveries. You should check out one of his books on load testing. He likes also writing about his experiences and what he's doing in the open source community. In his free time, he enjoys walking in nature and training his children in cycling. And right now, he works with me at Benevolent AI as an SRE, helping accelerate drug discovery. Welcome to the show, Neeran.
Hey.
So, tell me a little bit about yourself, man. So, obviously, I prefaced it as you're at SRE, but what do you do? What do you do at Benevolent?
So I'm managing the SRE team right now. So I'm managing slash leading. I'm quite technical in the sense that I'm quite involved in the day-to-day stuff that we're doing, and the whole aim of the SRE team or my role is to make sure that Benevolent has good uptime and is resilient to failures. So we want to make sure that when a pipeline run begins, from start to finish, there are no interruptions, and we are optimizing everything that we're doing there.
Nice.
To make sure that there's no blockers for developers on that end. Right now, because we are sort of shifting from a startup to a medium, it's a bit of release management as well. It's a bit of change management. It's a bit of everything involved.
Yeah.
But as we grow as a business, those responsibilities get spread out.
Yeah, it must be. That's a tall order, though, right? It's because it's not just for like a particular product area, right? This is for the entire company. And like you mentioned, obviously, Benevolent's a small company, but still, there's a lot of challenges with, making sure that everything's running smoothly, that services are up, that developers aren't being blocked, and then I guess responding to the constant fires that happen in just, development work.
Oh, yes.
Yeah, yes. I'm sure that must be tough. So I'm super interested in learning a little bit more about your background. So you have a lot of experience working on the cloud and working as an engineer, but what did you study in school? Did you study computer science? Did you do any other tracks?
All right. So I have a strange tale, right? So I did I did honors. I did a degree in economics and accountancy, actually. So
Nice.
I am not from from the technical profession at all. Actually, it was technical still, but yeah, my degree was all in finance. So I can understand all that jargon that people talk about on the news, and I actually quite like reading The Economist.
Yeah, it's great. I love that one. Yeah,
it's brilliant, and especially when they do all that weird jargon about the banking jargon and all these weird words. I understand all of them.
It's fun thinking high level, and I love economics is super interesting too. I learned a lot about that, but sorry, I didn't mean to interrupt.
Oh yes, so all of this, yes, it's very interesting. So, my technical experience actually began when I was about in my second year in university. So this is in London, City University. So I applied for an internship, right? So, before that, I used to just be, a games developer, right? So this is me when I was 20 or something. I used to just develop some games in my free time, right? Games in C or games in Python, Pygame, whatever, right? Just developing those. But so I got this little. So I applied for an internship. It was like a typical PHP sort of LAMP project. All right, so there I sort of went, and that's where my first experience in web began, essentially as like a PHP developer. So this was, when was this? About 10 years back or something. So from there, I started as an engineer. It was an internship. It was actually a company called Ecojo, which is defunct now, but. It's not. It's in slumber, actually. It's not defunct. It's in slumber mode. What that means is that we're not actively working on it. But what it was like a search engine for sort of organic products, eco products.
Okay.
So think of it like like something like not on your high street is an example. It's one of the UK companies. It looks at individual shops, and it sort of you can search for stuff like gifts or whatever. But this would show you like eco versions of that. So a bit of search engine logic, a bit of
nice.
Stuff like that. So I pretty much rewrote that in Python. So it was in PHP, and it was like a bit old, and I rewrote that in Python Django.
Wow. Okay, it's a good framework.
Yeah, so that was my first sort of experience.
Intro into engineering.
Yeah, intro into engineering. It was all self-taught, by the way. So I wasn't really, I would just grab a Python book, read it, grab like a object orientation book, read it. So none of my stuff is from university, actually, none of it.
That's impressive, especially because I know you and I've seen the things that you do. That's pretty impressive.
Yes. So and all the understanding of how CPUs work and all that all came from it was all self-taught. It's all sort of a need to understand for doing your job, and it's also just having that hunger to learn. Which I mean, I love learning. That's the best thing.
Yeah, it definitely is. So would you say that, I mean, I'm the same way, and I think a lot of the listeners that we have are self-taught because, when it comes to, I mean, engineering has been around for a little while, but, machine learning engineering and data science, these sort of new disciplines, they're kind of like all over the place. And you have people coming from all sorts of backgrounds. Like I was a teacher before I was a machine learning engineer. And I know that there's lots of stories like that. I actually was listening to this, I forget what I was listening to, but he was a priest. Who decided to take some courses on data engineering and now is a professional data engineer from priest to data engineer. But I think that speaks to the opportunities that this field has. It really is a talent-based industry. If you can do it, then and if you can show you have those skills, you can get a job, which I think is really awesome. But I also like that you mentioned like you learned based off like the needs of what you were dealing with, this practical sort of experience. And I find that actually is one of the best ways to learn, it's good to learn Python and kind of these sort of small examples, but when you actually have to deal with something in a real situation, it forces you to synthesize all of those things. And that makes your understanding much deeper. And it even opens it up for, to like kind of use that as like a template for how to solve other problems. So I definitely relate to that.
Yes. So from there, then I joined. So there was a company called CLW Rota. That was his name, but it changed his name, rebranded afterwards. But what it was, it provided Rota systems for the NHS. So NHS is,
Just real quick, Rota. What is a Rota system?
So Rota system is like, for example, you have all these consultants, locums, and junior doctors that work in a hospital. And there is a rota of when a doctor is supposed to come in, right? So you have think of it like a calendar.
Yeah. Okay.
Made for doctors, essentially. So that's a rota system for the NHS, and they were pretty much a monopoly on this rota system on the NHS because no one was doing anything like that. So they were actually based close to our office in London right now. So that's where again I was a developer, like an engineer there. Again, working on, again, it was similar, converting a sort of PHP app to Python. And actually it was, so actually there, it was actually quite a hard lesson for me. Hard lesson in the sense that we were using stored procedures. So I don't know if you work with those.
No, I have not.
Right, so stored procedures. A little
bit about stored procedures, yeah.
Okay, so stored procedures is something that people hate and or people can love, but this is how banks operate. Essentially, so a stored procedure is that so think of imagine you have to talk to a database without an ORM.
Okay.
And you wrote the ORM yourself.
Okay.
So that is, and a stored procedure is essentially when all of your logic lives inside of the SQL. In this case, so in other words, your app is very dumb. that what it does, it just performs, create, update, delete, and functions like that, and it just makes a call to the database to do that, right? So your logic is very dumb, but all the business logic actually lives in SQL functions.
Interesting.
Now that has because it's a bit functional. It's functional programming essentially, and the paradigm is totally different. It's totally different from the way you do things now, where you spin up, you use an ORM, right? The Django ORM or any sort of ORM, the JBDC or whatever you have. You represent all of your objects in some sort of objects native objects that you have. And then you do your logic sort of there, right? You say, okay, this person gets deleted here. I have to delete them from this dependency, etc. Yeah. There, you're literally doing all of that yourself.
Interesting. All in the database, essentially.
All in the database, yes. Yeah. So there are still some companies that operate like this. Like Zolando is one of them, which is a big player in Postgres. They do stored procedures. I guess the argument of stored procedures is that it's actually faster and better. It's faster.
It's direct, right? No network call or.
Yes. All of that happens in the database. All that load, everything happens in the database. So, I mean, back then it was because of the SQL stuff. It was so much work that I would start working in the morning with a full stomach, and by lunchtime, after like 3 hours, I would be starving.
Used up all that glucose, man, all that brain power.
Yes. I mean, I would stare at, massive 200-300 line join functions, join
that sounds
queries.
Like a nightmare, man. That sounds like a nightmare.
And I would understand all of that, and I would know how to alias that. And it was crazy. It was extremely technical. It was extremely difficult. But I mean, to be honest, I actually enjoyed it. I'm a bit of a sadist. I actually.
Yeah, you like the hard problems. Yeah.
Yes.
Yeah, you must if you're SRE, man. I mean, gosh, everything is failing all the time. Everything breaks. So you gotta it's stressful. But I guess you like that. You like firefighting.
Yes, it was firefighting. It was the whole challenge of it. Right? You knew that if you're gonna write a new, product, we were sort of like a product team as well. So you have a product. If you're building a new part of the product, you would have to, bootstrap all of this logic in SQL. And this is like proper SQL. This is not about, we're using Postgres, right? So this is the writing, how you do all this complicated business logic, coercing them and stuff like concatenating strings in SQL. Oh my God, it's nuts.
Yeah, you could do a lot with SQL though, to be honest. So I get that. Like I could see all the sort of things that you could do with that. You can, some people actually use it like as a programming language, which is, exactly kind of what's going on there.
Exactly what we were doing, yeah.
Yeah.
Like that. So, I mean, that was my experience. I worked there for about 1.5 years. And I mean, that learning, so it was difficult, but it was an amazing learning experience.
Yeah, I bet.
It pretty much set me up. And then after that, I joined Microsoft,
Nice.
Yammer. So Yammer got acquired by Microsoft. I joined a year after they were acquired. And I sort of started off as like an application support engineer. So essentially when queries come in, you have the customer facing people, and then eventually you escalate. And I was the last layer of escalation, essentially. The developer that actually goes and fixes the thing for the customer.
Yeah.
So the good thing was that we automated ourselves out of the job, actually. On that end, we pretty much created this internal system that was able to automate all of that out. And then we sort of, because we sort of automated ourselves out of the job, the managers back then basically said that, oh, okay, we don't have a job for you now, so you're gonna work in ops now.
There you go.
And I guess that was my first exposure to ops. Before that, I was a developer. I was a dev, like yourself, or not a machine learning developer. I was probably less advanced than that. But I was a simple developer on a project. So I'm pretty familiar with writing tests, TDD, BDD, writing JavaScript, all of that. I can do even now. So
that's fun.
Yeah, so
real
that's
quick,
fine.
while we're talking about that, you kind of differentiate like the term DevOps, right? So it's developer, so there's development, but then there's operations. What in your mind is the distinction between, and I guess focusing on MLOps, right? What does operations mean, and for both DevOps and MLOps to you?
Yeah. So operations is a operation covers various areas. So depending on which company you go, there's a different definition, right? Some people call operations IT. The IT team is the operations team.
Yeah.
Right. Then you have operations that are slightly different. I think it depends on what part of the world you're in, actually. So if you look at Silicon Valley, right?
Okay.
And if you look at the startups there, ops is sort of DevOps there.
Yeah. That's how I typically hear it.
And you have a separate IT team. Right. So, I mean, that's what most startups are like that, basically. The ops is DevOps. And then you've got London, which is slightly different.
Is that Europe in general, or is it just like London?
London is slightly different from the rest of Europe, actually. I would put it like that.
Okay.
Whilst in the rest of Europe, they take a slightly different approach to how they do DevOps. Essentially, the DevOps, IT, and is mixed in the rest of Europe. Whilst in London, it's more DevOps is actually DevOps. So I would say in London, DevOps is actually DevOps.
Okay.
And you will find it less and less the idea of IT being ops is sort of being moved away, basically.
Yeah.
So it's not there anymore. So it's sort of like a geographical a difference. And if you go in the Far East, it's totally different.
I wonder why. Why is that? I mean, me personally, especially after being involved with the community, I've learned that we often have a lot of the same problems. The same issues that we're dealing with, maybe at different scale, different domain. But I'm curious as to why there would be differences in the way that we look at, DevOps or information technology. Because in my mind, I often see it being conflated. Or maybe it's just I guess the sources that I'm reading, but IT and DevOps is kind of being the same thing. But I actually think about them a bit differently. I think I guess maybe I'm biased because of benevolence. Is kind of how I've learned what an IT team does. But I don't see them as. I mean, they have similar skill sets, right? I mean, they're problem solvers in some ways, but I often feel like they're just a little bit different. I would consider more of a software engineer on kind of the DevOps side of things versus an IT technician on the IT side of things, if that makes sense. Which, I mean, again, they may have very similar skills, and oftentimes they do. They just both like computers. They like to play around with things and tinker, but I feel like an IT person has to deal with I need setup to this thing. I need access, I need credentials to that or some sort of thing.
Yes, well, you are right, but at the same time, IT has a slightly different skill set. Okay. Simply because IT is more on the hardware side, I would say, but the thing is, in benevolence, it's a bit different because. All right. So when the internet went down in London, I was physically going there to fix it. But no, that is not a duty of an SRE at all.
You went to the cluster, or sorry, the data center?
Yeah, I've gone to the data center many times. Yes.
Oh man.
And now this is because of historical reasons, right? This is because of I sort of inherited that from the previous VP, who when he was there. So I sort of inherited it, but that's not what's supposed to happen. So it's different. So that one is not a good example. But in historically, IT has a different skill set. They're in charge of the office equipment, setting that up, making sure that's resilient, making sure your networking firewalls are running. If there's any events happening, making sure the equipment is set up properly. And stuff like that. I mean, think of it similar to, in your case, New York, you have you pretty much had Sarah doing all of these things for you.
Yeah, a lot of making sure everything is up. That's true.
Yes. So in London, pretty much IT does that, and the office team. So IT has a slightly different skill set, but there is an overlap and a gray area where both we do intersect. Yes.
Yeah. Now this is a perfect segue into what an SRE is, because I read this cool. I was listening to, or not listening, reading this interview with Ben Traynor, who was I don't know if he still is the vice president of engineering at Google, and also the founder of a Google SRE. He describes what an SRE role is as this. He says an SRE is fundamentally doing work that historically has been done by an operations team, but using engineers with software expertise and banking on the fact that these engineers are inherently both predisposed to and have the ability to substitute automation for human labor. In general, an SRE team is responsible for availability, latency, performance, efficiency, change management, monitoring, emergency response, and capacity planning. What are your thoughts on that definition of an SRE? I mean, it seems like that's exactly what you do.
Yes, that is true. Yes. So what you read is what I do. Yes. This is exactly what it is.
And from your, I want to hear from you. What does an SRE care about? Like those are very, those are like a lot of things, right? But if you could summarize in like a few words, what does an SRE really care about?
An SRE cares about what's in the title, resiliency, right, and reliability. So it's reliability of the of all the infrastructure that the business logic runs on.
Okay.
So all that's what an SRE cares about.
Okay, cool. And how does that role relate to something like an ML engineer or a software engineer, or I guess data scientist is more like a little bit different, but let's say like your traditional software engineer, like Ben Traynor was saying, they typically have a lot of software experience because you have to, you're dealing with a lot of engineering problems, but how are they different?
So I would say SRE is more of a secondary discipline, as in what happens is that normally you would transition into an SRE role, right? So you would be an engineer in your daily job, but then after 3-4 years of doing that and having some exposure to ops on your daily basis or working with infrastructure, you would transition into an SRE role. So it's sort of a secondary discipline. And you sort of gain.
You don't go to college and then come out and go straight to an SRE, probably, right?
No. Ideally, you would want to gain a bit of experience, because if you go straight in, then it could be difficult to grasp some of the concepts that are there. Because you need to be a software engineer you need to be able to code. So when we, for example, have an interview, for example, for an SRE, we give them software engineering coding problems.
Okay.
Right. So you need to be able
to know algorithms, data structure, system design, architecture, and that makes sense. Yeah.
Yes, but the system design architecture part you will gain from experience. So as you're a software engineer and you're exposed to various different projects that you've worked on, and working with database, etc., you gain that experience. 2-3 years into the job, and then you move into SRE.
The skill set, obviously, like I've just seen some of the things you have to work. You have to work Kubernetes, especially because like for if you're managing a cluster, obviously you need to know Docker. You need to know how to work on virtual machines. So I'm assuming you need to know Bash. All sorts of things to navigate that sort of landscape. But what other skill sets do you have to have outside of the traditional engineering things? Because I'm sure there's some soft skills as well, right? Like, I mean, for example, I would get stressed out if I had to put out all the fires you had to put out. It would just drive me a little crazy. And I guess maybe for me, it's hard for me to context switch that quickly. But you must have either that you like that, or you've gotten good at managing those sort of those like expectations from everyone else. Oh, this is down, we need you to fix this now. Like, I guess dealing with a daily urgency of things.
Yes, I guess what you will mostly find is that the SRE or the DevOps team mostly find themselves. It also depends on the sort of industry you're in, right? Now, if you're working on a real-time application, right, that if something breaks, people, your customers will see it straight away.
You lose money,
right? You're losing money if something's down. Then it's a slightly different environment to a research-based workload. Right, like if you look at, for example, say Benevolent, who do drug discovery. Now we don't have external-facing customers that, for example, are if this particular infrastructure goes down, suddenly they can't message people anymore.
That's right.
Stuff like that.
Much more researchy, and it's kind of like,
yeah. And our customers are pretty much, the developers, right? If something goes down, they pretty much say, "Oh, I can't run my job," or something like that.
That's me. As Neeran, what the hell's going on? I need help.
Yeah, yeah. So you would say that. So, but you're not gonna. I don't have to refund money to you, right? But so now that's different, right? Now, if you have now, so I mean, I've been in both environments where you have a high. We've got like 100 microservices, and one of them has gone down, or 3 of them has gone down, or 20 of them have gone down, and you get an alert early in the morning at 5 a.m. that the whole database has gone down, and you have to wake up and sort that out. Yeah. In the environment I am currently, where it's a bit more chill. You don't have David at 5 a.m. messaging me.
I need this now.
Yeah, I need this now because there's customers on my back. No.
Oh, God, yeah.
Yeah, so it's not like that. So it's a bit more chilled, I guess.
Nice.
In that sense. So that bit is sorry. What was the original?
It was just basically about like that those soft skills as well of an SRE. Like
you need to be able to manage your time. Manage your time. You also need. Because what fundamentally what SREs do, they continuously changing infrastructure, right? You also need skills to be able to convince people or
get some buy-in.
Get some buy-in, de-escalate situations. Because people can be very passionate about the technology they work with.
Yes, I get that. Yeah.
And if your job is to make the infrastructure more resilient, you might have a conflict of interest. Right? That they want to use this hot new technology that just came out. And the SREs look at it and they're like, no, we can't run this. And they've already done the work and they're like, I have a deadline next week to do this. And then you sort of have a conflict right there that no, we can't. Like this was very common, especially during the early Docker days, actually. When Docker was brand new, all the devs it was like a candy shop for them, right? All these new things coming out.
Docker is pretty awesome though, so yeah.
It is, yes. And they were like, we want to run Docker in production right now, right? But then you have the DevOps team or the SRE team, and they say, you can't because we don't support it yet. And it's got these tons of bugs that no way we are deploying this in production.
Again, you're thinking about reliability. You're thinking about resiliency. You're thinking about like maybe they want to like solve the cool problems, and that's great. That's what they should focus on. But you're like, no, I need reliability.
Yes, reliability. I want to make sure that whatever is being run keeps running. Consistently, efficiently, and all that. So you need that. You need those soft skills to be able to de-escalate situations.
Yeah. This is what I want to get into now is talking a little bit more about like what an SRE focuses on. Now, in my mind, we were talking about this before. There's resiliency within the context of networking, resiliency within the context of compute, and then resiliency within the context of storage. So I want to talk about that, but kind of framing it in an MLOps perspective. So let's start with first from your perspective, because we do a lot of machine learning at Benevolent. What is MLOps from an SRE's perspective? And again, there's like a million different answers on what MLOps is, but I would love to hear from, within this context of, reliability, what does that mean to you, MLOps?
Yeah, so MLOps is essentially all the infrastructure that is built to support machine learning. Right, so we've got lots of new libraries that are coming out, new tools that are coming out that support machine learning. And this is not going to stop. This will continue to increase.
Yeah, it's going to change.
Right, and what we are seeing is that when a solution like that comes out, it gets involved on all aspects like operations, from top to bottom. You see the infrastructure. I'll give you an example, like Kubeflow. Kubeflow is a brilliant example, right? Because it literally takes over the whole Kubernetes cluster when it's deployed. And it is it's a whole framework by itself. You could just be a Kubeflow engineer if you want.
Yeah,
right?
There's a whole ecosystem. I think that's a great point, because oftentimes people think that like Kubeflow is one thing. I'm like, no, it's like actually like a whole ecosystem of different things, and like you mentioned, it actually could take up a whole cluster running all of those things.
Yes. So all of that now suddenly when you say Kubeflow, right? Now you're sort of going into you're going into the operations part, the ops part, and it's got the machine learning aspect, right? Running it in various clouds and stuff like that, so in that aspect, it's quite different. Then you have stuff like Polyaxon, which is this machine learning framework for Kubernetes that is again a whole new platform coming out. Then you have the different places where you keep all the data, right? Because ML cannot be without the data, right?
Oh yeah, that's the power of ML, right? Learns
yes,
that's garbage in, garbage out.
Yeah. yes. So and you need that data. You need to store it somewhere, right? And depending on what data you're working with, if it's public data, if it's private data, these are whole. So MLOps is actually quite a big topic.
Yeah, it is. It really is. I mean, there's a whole community around it, man. It's
I know.
There's even now some new fields popping up like data ops. So like there's I mean, yeah, it's I don't know if it's good or bad, but I do know that sometimes it is helpful to devote some time just to one single topic because it can encapsulate many different things like you're mentioning, like all sorts of things that are involved by MLOps.
Yes, I think it's becoming more formalized. It's it's starting to take shape. Some of these projects used to be just playgrounds, how they began, but now it's starting to take more shape into something more. Like these things already existed, by the way. It is like as tools within organizations. It's that no one just gave a name to them, or they would simply be part of the analytics team. Would just be ML somehow. But yeah, it's sort of evolved into a whole new discipline by itself.
Yeah. So let's keep going with resiliency. Let's focus on that. So now, within the context of machine learning, how would you define resiliency? What does that mean? Does that mean that the model itself can adapt to various situations, or is it more from like this infrastructure component where it has it's up and running? There's if you have all the resources that you need for that endpoint, let's say that you're serving it from, it's there's security there. For example, that only people within the company have access to that endpoint. So I'm sure there's lots of ways that you could frame it, but from your perspective, what does resiliency mean for within the context of machine learning?
Yes. So machine learning, basically, the way we categorize it is essentially batch jobs to us. So we sort of categorize all the machine learning because we think of them as like just jobs running, long running jobs or something like that.
Jobs. Okay.
Right. So we treat them as batch jobs, and we want to make sure that they can run from start to finish without anything stopping them. Or even if they are stopped, they are resilient enough that they can resume from wherever they were stopped.
Yeah, great.
Right. So because with the infrastructure, you can't, networking issues happen all the time. You can have a bulletproof infrastructure, but you will have some sort of networking issue, and it will go down. Right. So that sort of stuff is what we want to cater for, right? You want to put in checkpoints. You want to put in, circuit breakers. You want to put in timeouts. You want to put in retrying. You want to put in all of these extra little things, bolt-ons essentially, to make your bad job more resilient.
Yeah.
Is what we focus on from the SRE side.
Yeah. And then what about networking? So obviously with a common way to serve your models, right, is as through a live endpoint. That makes, at Benevolent, we have kind of this microservices architecture, but there's a lot of challenges that come with that, right? There was actually someone that asked in the community, what are the pros and cons of microservices? And I always keep in mind, what Martin Fowler said about, like sometimes it's actually better to start with a monolith because of the complexities that come with a microservice. I've seen it myself, man, just like, building these systems, working with these systems. There are a lot of things that happen, like you mentioned, like you could have everything right, but just networks go down. So within the context of resiliency, how do you deal with some of those challenges of, microservices, machine learning and networking and all of these things and making sure that everything is working?
Yes. So I think the main bit here is to just make sure you're picking the right technologies. So the answer to if you have microservices or you shouldn't To be honest, it's not for the SRE doesn't care that much about that. Right? You can have a monolith or a bunch of microservices. Right? We will. Our aim is to just provide you the infrastructure, which is actually a DevOps thing. In Benevolent, it's a bit different. We're sort of DevOps and SRE at the same time. But what we look at, and whatever you decide, we will support, and we will obviously advise you on how you can make that resilient. So in that aspect, essentially, you are our customers. The developers are the customers that we work with.
And so you're willing to meet all of those needs. If you want to have you want to make a bunch of network calls over your, in your machine learning system, you make that happen. And I'm sure there's some things that you need to do to make that happen. Like, let's say, I know recently we've been thinking about the load balancer, right? I forget what was the name of the one that we were using before, but we've moved to a newer one or something like that, right? So maybe do you have to think about the best tools to make
yes. So that one was actually driven by developer demand, right? So we weren't using gRPC before. Yeah. And now, so developers, wanted to switch to gRPC now. So we changed the infrastructure to make it compatible with gRPC now.
Okay.
And we made it more resilient in the process of it. But that's the motivation behind it, that we will change the infrastructure to suit your needs.
Nice. That's good. And then let's talk about now compute. So compute obviously is pretty important for machine learning, right? Because there's certain jobs that require certain hardware, right? You need a GPU, or you need a certain, sometimes you need to run it across multiple machines. So there's a lot of, I'm sure, concerns from an SRE's perspective with regard to compute. I can think of, let's say, managing costs or dealing with under and overutilization. So let's talk a little bit about that.
Yes. So especially with MLOps, right? You have lots of GPU demand or lots of compute demand, right? We want to use, 20 CPUs or 10 CPUs or
100.
Something insane like that for running your jobs, right? And you need, the GPUs need to have the right amount of memory and stuff like that. So in that aspect, we would provide the tools to enable you to do that without much disruption. So whether it's depending on what cloud you're using, you would deploy the correct tooling there to make it such that, like, for example, auto scaling. So when you ask for 100 CPUs, GPUs, whatever, it would auto scale to that amount without any sort of disruption. But in the background, what's actually going on is that we set certain limits to that.
Yeah, I was just about to ask about that.
Yeah, so it's not like you can scale infinitely. It's that we have a limit, and this is where budgets come in actually. So SRE have to, there's a cost to resiliency, right? But right, we want to make sure, because it's additional stuff. It's additional stuff, right? Because we're asking you to do all these bolt-ons. Not only can that incur a bit of technical debt, that can also incur a bit of cost as well that we have. So all these extra things we are running to make sure that you are resilient in your thing incurs that extra amount of cost that we incur on a monthly basis or whatever, however you account it. So it's that. It's also making sure that we understand what sort of workloads you are running and recommend the right technologies. Right. So if you are running a very linear job, for example, that goes through a CSV and isn't going through a CSV isn't complicated or parallelized in any way, we would actually recommend that and if you want to analyze a data set, right, that is terabytes long and you've got say 1,000 1 terabyte files inside of an S3 database, right? Now we would here recommend certain technologies that we wouldn't recommend for a linear job, right? Certain technologies that are more resilient, something like Spark, and making use of the Hadoop ecosystem. There now, so I mean that's where we get into big data. Now, as you mentioned, the data engineering or something like that. But
that's another component of resiliency, right? I mean, I think we've talked about this a few times on the show, but MLOps is a little bit different from traditional DevOps or software engineering in the sense that you have these added elements of complexity. You have the data, Then you have the randomness of the actual model itself, because it learns behavior not from hard-coded logic, but it's learned from the data itself. But then you also have this aspect of, once it's live, you need to monitor it and make sure that it's doing good. But sometimes knowing whether it's good or bad is a hard it's a hard question to answer, because there's not always immediate feedback. Maybe, for us within the context of what we're doing at Benevolent, we won't be able to really know the answer until we test it in an assay and spend a bunch of money on it. So there's these added things that make it more difficult. But a big part of that, I think, even before you even get into any of the cool stuff, and this is something I'm thinking about a lot in my personal time, is having access to that data. So let's talk a little bit about, storage for your machine learning, data sets. There's lots of different data sets, and it depends upon the use case. Let's say if you have a batch job, maybe you don't need quick reads, but maybe if you have an online data or online sort of application, then maybe you need something that with lower latency. So I'm sure you have to cater to all these needs. From your perspective, how do you navigate the whole space of, data and databases and storage? Because there's a lot out there, even some companies that are dedicated to just that layer. And personally, I think it's actually really important to get that part right, because you can't really do any cool ML stuff until you have access to the data that you need, and it's organized, it's reliable, it's this. Anyways, I'm talking too much, but yeah, go ahead.
Yeah, so it's all about exposure. So as in, from the SRE side, we want to first understand the use case, right? So is it gonna be read heavy? Is it gonna be write heavy? Are you gonna do concurrent writes to it? Are you gonna, how do you plan on using the data that's inside of it? How do you want to optimize it? So stuff like that is what we care about, right? Does it need to be a relational database? Are you thinking about just dumping it in a, transitory store, like how we do here, right? We got MySQL databases that we just dump stuff in temporarily, then we take it out and chuck it somewhere else. So like that sort of stuff. And if you're creating, or if you just want an object store, right? Something like S3 where you can just chuck in anything you want.
I love
that, and not care, right, about what format it's in.
Yeah, exactly. Or a schema, or just I could literally just throw whatever I want in there. I love that.
Yes, or if we have a more data warehousing scenario where, the big data we have, like we used a bit of BigQuery in the past, right? And now we're sort of moving on to Redshift, which is a massive data warehouse analyzing, where people can just run massive SQL queries and it will just query all this data in the background and give you the results back. So based on the requirements that are given by the developers, and here we would actually sit with you, understand exactly what you're trying to do, and then recommend the right data store which will work for you.
Man, I just want to highlight, this is challenging. You have to know a lot of different things, right? Like you have to take, and that's the thing, like, I'll come to you with my specifications of things that I'm trying to do, and you'll be like, okay, we can do this, we can do that. So you have to understand these things pretty well. Again, I think that's a challenge, and that makes sense why you can't just, out of school, go straight to be an SRE. Like you need some skin in the game, you need some experience, some scars for dealing with stuff in production. All right, we're gonna a few more topics before I let you go back to your day, man. But I want to talk a little bit about security. This is something that I personally never really thought about, because I'm like, security, I don't really know anything about that, but I know that's a big part, because we do need that. We need to make sure that there is, that what we're working on is protected. And I can imagine for certain industries that's more important than others, but in general, security is a big thing. So I would love to hear a little bit about your thoughts on security, the role that it plays in MLOps, and just anything around that.
So there's one thing, right? So when everything is operating as normal, but normally the management or stuff like that don't really notice anything, right? But when something breaks or a breach happens, suddenly, everything is up in fire, right? This happened, or something goes down, right? Everything's on fire, there was a breach and something went in, stuff like that. So security is something that's one of those things that you really have to pay attention to. And some of it's just, thinking of scenarios that can happen. They're called risk assessments, essentially, that you need to conduct from a technical perspective. So normally what you have a security team that's assigned, and the security team, so again, the DevOps team normally would do this, but the DevOps team the security team would be a customer of, the security would be a customer of DevOps team, right? So security team would look at the infrastructure, the whole setup. They would do a risk assessment of things like, for example, if a former employee leaves the company and they still have access, what sort of damage can they do? What sort of offboarding we should do so they lose their access? Right. And some people have different levels of access, right? Now, if you try to say like the amount of level access I have access to every single equipment in this whole company in all the offices, right?
Godlike it.
Yeah. So to take away my access, you need some special actions, right? But if you want to take away, say, for example, a scientist access, that's easy because they only have access to Cambridge, right?
Just a few things,
so just a few things. So it's managing that different level of policies is that. But security. So it's almost like every engineer needs to be a security engineer. That's the sort of the mentality you have. So whenever you design your software, so even a dev that is a machine learning dev, right? Now they're normally worried about what sort of data they will analyze and stuff like that. Now, but they still have that. If I were to put it in legal terms, they have this fiduciary duty. So again, I told you I have a background in economics and accountancy. So so I've studied law as well. So so they have that fiduciary duty to actually make sure that they are respecting the use of the data, right? Because we have lots of restricted data sets.
Patient level data, things that are, we don't want to.
I mean, some of that you can't just take it and merge it into another data set to boost your results
or whatever.
So and that is security. That is making sure that these things don't mix. It's also data management. It's also data. That's why we have a data manager, right? We have data manager. We have so every engineer has that duty to, and also even just picking the technologies, right? If you pick a library that is super old, right, something that's compatible with Python 1.1, right, or something like that, and you try to deploy it on our infrastructure, obviously you're going to be you won't be able to say no to that. So devs have actually more security responsibility than they think.
That's a great point, man. And that's what I've recognized that when I first started that I really didn't pay enough attention to these sorts of things. But I think you're right, man. We do have that fiduciary duty. We do have that responsibility to make these, because honestly, we're the ones that are doing it. Like, I mean, how the hell would you know what like all these things, like you're thinking high level. So it's really, it helps when each individual person is thinking about that, both from, someone like myself or the SRE who's thinking about the high level thing. Now, the last thing
one thing I also want to touch on this is that it's also reactive response, right? I mean, people will screw up. People will push, secret keys, passwords in Git, in Git and stuff. But so it's also making sure that you know how to respond to those scenarios. Right. So as a developer, you need to be educated or have the right actions that if you do take an action like that, who you need to talk to. So it's every developer's responsibility, not just SREs or, So and ML has an aspect of that, yes, because you are developers in the end.
Absolutely. And I think like you mentioned about it's better. I would say it's probably better to be a little bit proactive than reactive, thinking about some of the things before versus just, on the fly, like, oh shit, everything's falling apart. I need to, how did I didn't think about not pushing my credentials, or whatever. And I know this because I've done it before. So I've learned, I've learned the hard way. But all right, this has been so awesome. And I'm just, one last thing that I want to cover, and this is going to be probably a whole topic in and of itself. But a big thing that it's coming up a lot right now is monitoring, right? It's very difficult sometimes to have insight into what your model is doing in production when it's actually being used. But there are some tools that are coming out to help make that a little bit easier. You know, I know at Benevolent right now we're using things like CloudWatch, Prometheus, Thanos. Let's talk a little bit about the, you know, monitoring. So from your perspective, what role does that play for you to manage everything?
Yes, so monitoring is absolutely critical to what an SRE does, right? Without monitoring, we cannot know what's going on.
Yeah.
Right.
I got you. Yeah, you're good. Just there you go.
There you go. Yeah. Okay. Yeah. So monitoring is absolutely critical to what we do. Without it, we're blind, essentially.
Yeah.
Like for example, if now there's layers of monitoring, right? How deep you can go, right? So you start off with some basic monitoring on, say, a Kubernetes cluster, where it just tells you if a pod is up, down, or if a service is up, down, right? Now that tells you some basics, right? That you know, there's some basic alerts in that, like if a pod keeps restarting, right, because of running out of memory, right? So that could be a developer running their job and constantly being run out of memory, right? So that means they need to increase their memory. Now I wouldn't know that if I didn't have monitoring, right? The dev would have to manually go in there, you know, look at why his job is constantly being killed, and then deduce from there that I'm running out of memory, and then increase it that way. But if you have monitoring, it gives you that visibility into the whole infrastructure of what is actually going on, right? You can also look at, you know, the amount of data that's being passed across the network. You can look at the amount of data we are storing in different volumes and stuff like that, and you can then generate reports, like more high-level reports on expenses, like we're using.
How much we're using, you know?
Yeah, how much we're using and how much each team is using, for example, the amount of compute each team is using, and then from that you can, you know, budget according to that.
Yeah. A real example is, I remember we were using too many resources on my team, right? And the SREs were like, hey guys, you guys need to tighten that up a little bit, you know, make sure that you're actually thinking about exactly how much you need. And yeah, we've had to do that. And it did, I mean, hopefully it made a difference, but I know that just having that conversation helped us, you know, be more aware, because we kind of were just like blindly setting, you know, limits and requests, you know, for a certain job without really thinking like, oh shit, you know, we're using a lot.
So it tells you, you know, your requests that you have and the limits that you set. And if there's a massive difference between your limits and requests, you need to put your limits down, basically. So there's also, there's like an incident response aspect to monitoring, where you set up alerts, like, you know, you set up an alert on something very important, right? Like, for example, maybe some cube flow that is critical on how people make models. If that bit, for whatever reason, it's going to be, you know, you won't be able to function. Right, so you have the incident part where it raises an alert and the relevant team goes in there and fixes it, right? But then you have the more higher level aspect where you can churn. I mean, part of a duty of an SRE is also capacity planning, right? So we're constantly looking at, for example, the size of, like if you look at our, you know, our private data center in Walter, where we had a limited amount of storage on the NFS share. Right, so we sort of predict that, okay, in the next quarter we will run out of space, so we need to do something about that. So it's about capacity planning. It's all different. It works on all levels: operational level, tactical level, and also strategic level.
Wow. So it's much more than just the. So yes, I love hearing this stuff, and I hope that others as well, because it's great to think about not just, you know, my little thing. You know, I'm always worried about my model, but there's so many other things to think about that actually makes that work. You know, like you mentioned, capacity planning. You know, like I may not be anticipating. I may not be aware that all these other teams are using all these resources, and at some point that's going to actually affect my service or whatever, my product. But you are thinking ahead and making sure that that doesn't happen, that there is no problems, that, you know, everything is running smoothly. So I love hearing that. So, you know, monitoring is much more than just the itty bitty, you know, nitty gritty details, but a higher level of how everything is actually playing together and anticipating appropriate responses to that.
Yes.
Man, this has been so awesome, Neeran. I'm going to definitely have to bug you for another one of these because there's so many other things that I'd like to talk about. But I think for today, this has been excellent. I'm sure that the MLOps community appreciates this. One last thing before we go, and we're going to, again, I'm going to put links to some of the cool resources that Neeran has been working on. He has a book you should check out on writing a load balancer with test-driven development in Python, which is a great read. I advise you to check that out. But I'm going to put some stuff so you guys can reach out to him, and hopefully we have him again. But before we go, Neeran, just from your perspective, what's one little tidbit of advice that you would give to the MLOps community? And it could be something small, something that you think about right now, something that you care about, anything. What's something that you'd like, just a little tidbit of advice for us before we go?
Yeah, so I think the direction that the MLOps community is heading is great, and I think they should keep heading towards that. I really love that some of the libraries that come out are very they're the full stack essentially. They the people who are working on these need to have full understanding of the full stack. I really like that some of the libraries have certain features that I didn't expect them to actually have. And what I would actually encourage is more people to get in there, start contributing to some of the open source projects that we have. And really, bring the expertise in that area, and ML Ops needs that. And I think it's a great community, and I think we should continue, making it more have a structure around it.
But even
the odd experimental stuff that people are doing, that holds tremendous value. Even in my eyes. So we should continue doing it and continue. A lot of people work on these projects, in a hidden dark room, and they never expose it to the world.
That's so true.
I think we should continue doing that. I think MLOps community is brilliant.
Yeah, I really love that piece of advice, and I hope you guys take that to heart. For anyone who has a little bit of spare time outside of work, think about contributing to an open source project. I haven't even had the chance to do it myself, but it's something that I know it's on my heart, I'm passionate about, because that's what actually has driven so many advances in our field, right? Is people actually putting up this stuff and us using it, making it better, incorporating this into that. And like you said, it's more, it could not have been done by a single discipline or a single person.
Yeah.
It's an interdisciplinary organism of things, and like you said, it's full stack. Some things that you weren't even thinking about because maybe that's not from your perspective, but yeah, we need more of that from different perspectives to make it, continuously evolve and grow. But yeah, that was a wonderful piece of advice. Guys, I want to thank you for listening. And Neeran, thank you so much for taking the time to speak with us. I hope that everyone has a great rest of the day. And we look forward to the next coffee session.
Yeah, see you, man. Bye.